How to multiply octal numbers. In this tutorial, we will describe how to multiply octal numbers. In the terms involved in math operations video, we discussed terms involved in multiplication. Since we will be multiplying octal numbers, the operands involved in multiplication are multiplicand and multiplier. The result will be the product. For example, let us multiply the following. Alright, so we're going to perform a multiplication using octal numbers. For this example, it's no different than anything else. We deal with, we have a multiplier and a multiplicand, and when you multiply the two, you get a product. For this example, we're going to use the value 206 times 125, and we should get a product 25,750. Towards the right, we have is octal representation. For the value 206, its octal representation is 316. For the value 125, its octal representation is 175. Before we begin computation, if we look towards the top left, since we're dealing with the octal number system, we want to show like the base 8. So we have 8 to the 0 is 1. 8 to the first power is 8. 8 to the second power is 64. 8 to the third power is 512. And 8 to the fourth power is 4096. Towards the top right, we have this set of octal numbers. It's the values 0 through 7. These are the only digits that can be used to represent octal numbers. So let's begin our computation. When we do perform multiplication, it's pretty much the same as when we are performing multiplication in the decimal number system. So we have the value 316 times 175. The value at the bottom, we're going to start off with its least significant value and multiply it times everything to the top. In this case, for the 175, the least significant value is 5. We're going to take 5 and multiply it by everything on the top, which is the value 316. So let's begin. So we start off, we have 316 times 5. All right. So 6 times 5, we get the value 30. And so we have to convert this to octal. So we divide 30 by 8, and we get 8 go into 30 3 times. And 3 times 8 is 24. So we want to subtract 24 from 30. We get the value 6. And what this is saying is that 30 is represented in octal by the value 36. So that means 6 goes here, and the 3 is carried. So the next value we have is 5 times 1 is 5, plus 3, we get the value 8. So we have to convert that to octal. So we just say 8 goes into 8. That'll be 1 time. 1 times 8 equals 8. We subtract. And it will be the result, or the remainder, 0. And what this is saying is that the value 8 in octal is represented by the value 1, 0. So 0 goes here, and we have to perform a carry. So the next significant computation is we have 3 times 5, which will give us the value 15. And then we have to add the carry. That will give us the value 16. And so we have to convert 16 into octal. So we say 8 divided into 16 will be 2 times. 2 times 8 is 16. Subtract. We have the value 0 is the remainder. And what this says is that the value 16 is represented in octal as 2, 0. So 2, 0 is carried over here. And so that represents 316 times 5. We can put that here. So we put 2, 0, 0, 6. All right, so let's clear this out for the next computation. Okay. All right, so the next significant column or digit inside the value 175 is 7. So we take that and multiply by 316. All right, so 6 times 7 is 42. And we have to convert that to octal, so we will divide it into 42. 8 goes into 42 5 times, and that represents the value 40. So we subtract 40 from 42, and that leaves us with a remainder of 2. So what this says is that the value 42 is represented in octal by the value 52. So 2 goes here, and then we carry the 5. So then we perform our next computation is 1 times 7, which is 7, but we have to add the 5. And of course we got 7 plus 5 is 12. But we have to convert that into octal. 8 goes into 12 one time. 8 times 1 is 8. We subtract. That leaves us with the value 4. So what that says is that the value 12 is represented in octal by the value 1, 4. So 4 goes here, and then we have a carry of 1. So the next computation, we have 3 times 7 is 21, and then we add the carry of 1, and that, so that gives us the value 22. So we want to convert that into octal, so we divide it by 8, goes into 22. And so 8 goes into 22 2 times. 2 times 8 is 16. So we subtract 22, subtract 16, gives us a value of 6. And what that says is that the value 22 is represented in octal by the value 2, 6. And so 2, 6, it goes right here. So what it is an octal 316 times 7 is 2642. We can put it here. Just as we do in multiplication, you kind of, each time you come down, you're shifting towards the left. So our 2 would go here. So we have a 4, have a 6, and a 2 is right here. So let's clear out for our final computation. Okay, since the next computation is 316 multiplied by 1, And as we know the basics of multiplication, anytime you multiply anything times 1, you really get the same value. So we'll go ahead and put the 6, 1, 3. So 316 is here. And we can start performing our addition. So we want the least significant column, which is here. We bring that down as the value of 6. 6 is already shown up here in the set, so it's already in octal form. Next value is we adding 0 and 2, we get the value 2. And the next significant column, we have 0, 4, and 6. When we add that up, we get the value 10. So we have to do computation here. We have to say, so we know that 0, 4, and 6 add up to be the value 10. We still have to convert that to octal. So we have to divide that by 8. 8 going to 10 one time. 8 times 1 is 8. We subtract. We get the value 2 as the remainder. And what that says is that 10 in decimal is represented by the value, well actually 1, 2 is represented in octal. So the value 2 goes here, and we have to carry the 1. So we have the next significant column, we have the values 1, 2, 6, and 1. And once again, that adds up to be the value 10. So we could use the same computation. We get the value 1, 2 for octal. So the 2 goes here, and the 1 is carried. And when we add up the next significant column, we're adding 1, 2, and 3. We get the value 6. Now this is, so we have 6, 2, 2, 2, 6. And that's supposed to be, when we multiply the octal value, 316 times 175. What we're going to show is that when we convert this to decimal, that is the value 25,750. So we can, let's erase this up here, shouldn't matter. Let's see. All right. Now, we said that since we're dealing with 8 or any kind of conversions, you want to think about the positions of the digits. So the digit in this case, 6 is in the 0th position, 2 is in the first position, the next 2 is in the second position, the next 2 is in the third position, and the 6 is in the fourth position. So when we go out here to compute, we want to show that, so we're going to have a 6 times 8, and we said 6 is in the fourth position, its exponent would be 4. Then when we have 2 times 8, we said that 2 is in the third position. Then we have another 2. It's in the second position. Then we have another 2. It's in the first position. Then we have 6 times 8 to the 0th power, and we'll perform some computations. Let's break it down even further. We say 6, and as we mentioned about the notes at the top left, they're coming in handy. We already indicated that 8 to the 4th power is 4,096. And so the next one is 2 times 8 to the 3rd power. We mentioned that is 512. And then we have 2 times 8 to the 2nd power, which is 64. And then we have 2 times 8 to the 1st power, which is 8. And then we have 6 times 8 to the 0th power, which is anything to the 0th power is 1. And let's now break this down further. We have 4,096 times 6 gives us the value. This is 24,576. Plus we have 512 times 2, which is 1024. Sorry about that. Let's erase that. 1024. Then we have 64 times 2, which is 128. Oops. Then we have 2 times 8 is 16. And then 6 times 1 is 6. So we have 24,576 plus 1024 plus 128 plus 16 plus 6. And it indeed come out to be 25,750. And this is what we wanted to show. Next, let us perform another octal multiplication. This time we will multiply numbers with a decimal point. Okay, so we're going to perform another multiplication. This time we're dealing with the multiplicand, the multiplier, and the product. For this example, we're going to use the decimal value 243.25 and multiply by the value 150.50. And we should produce a product of 36,609.125. Towards the right, you'll see is octal representation for the value 243.25. We have as octal representation 363.2. And with respect to the multiplier, the value 150.50, its octal representation is 226.4. Towards the top left, the same set of notes that we have, except we take it a little bit further because we're dealing with a bigger number here. So we'll just mention 8 to the 5th power is 32,768. And also, when you have a decimal to the right, you really have a negative exponent. So we're expecting 1 towards the right. So when we have 8 to the minus 1 power, we have that value is 0.125. It's going to come in handy, as you see, when we perform the computation. So let's compute. All right, so since we're dealing with the decimal digits here, we got decimal points in these values. We can see that 363.2 and 226.4. We have 2 digits towards the right. So when we perform this computation, we're going to remove those decimal points. So what we're going to do is take the value 363, and it would have been 0.2. This remove the decimal point. Up. Hold up. Okay. All right, so then we multiply this by 4. And at the end of the computation, we'll just have to consider that we're going to have to compensate for the 2 digits from the right side of the decimal. All right, so what we're going to do is the same thing that we did in the previous example. So we multiply the least significant on the bottom times everything on the top. And in this case, it's the value 3632 times 4. So let's compute. So we have 4 times 2 is 8. But 8 is not represented in the set of octal numbers, so we have to convert it. So we say 8 goes into 8. And 8 goes into 8 one time. 8 times 1 is 8. We subtract. We get a remainder 0. And what this says is that 8 is represented in octal by the value 10. And so 0 goes here, and a 1 is carried. So we have 3 times 4 is 12 is our next computation. So we have 12, and then we have to add the 1, which would give us a value of 13. So we have to convert that into octal. So we say 8 goes into 13, and 8 goes into 13 one time. So 8 times 1 is 8. We subtract, and we get is 5 is the remainder. And what this says is that the value 1, 3 is represented in octal as 1, 5. So 5 goes here, and the 1 is carried. So our next computation is 6 times 4, which gives us the value of 24. But we have to add the carry, and we get the value 25. So we have to convert that into octal, and we divide that by 8. So 8 goes into 25 3 times. 3 times 8 is 24. We subtract 24 from 25, and we get the remainder of 1. So it says that 25 is represented in octal by the value 3, 1. So 1 goes here, and the 3 is carried. So the next computation is 3 times 4, and we get the value 12. And then we have to add the carry. That gives us a value of 15. So we have to convert 15 into octal. So 8 goes into 15 one time. So 8 times 1 is 8. We subtract. We get the value 7 is the remainder. And so what that says is the value 15 is represented in octal as 1, 7. So 7 goes here. And of course that carry of 1 is there. So this represents the 4 times everything on the top. So it's the first computation. So we go ahead and put the value up here. So we have 0, 5, 1, 7, 1. All right, so let's clear up the real estate so we can perform another computation. Okay. All right, so the next significant value is 6. So we're going to take the value 6 and multiply by everything on the top. But we're going to remember we're going to remove the decimal point. So we got 3, 6, 3, 2. This time multiplied by the value 6. Okay. So we have the first computation is 6 times 2. We get the value 6 times 2 is 12. So we have to convert that into octal, and that goes in, it says 8 goes into 12 one time. 8 times 1 is 8, and we subtract 8 from 12. We get the value 4. 12 is represented in octal by the value 1, 4. So 4 goes here, and the 1 is carried. And then we start off with the next computation. So we have 3 times 6 will produce the value 18. Then we have to add the carry of 1. That will give us the value 19. So we have to convert 19 into octal. So we divide it by 8. And of course, 8 goes into 19 2 times. 2 times 8 is 16. We subtract 16 from 19. And we get the value 3. So that's saying that the value 19 is represented in octal by the value 2, 3. So 3 goes here, and a 2 is carried. So then the next computation is 6 times 6, which is 36. And of course we have to add the carry of 2. So that gives us the value 38. We have to convert 38 into octal. So 8 goes into 38. And we have that is 4 times. 4 times 8 is 32. And we subtract 32 from 38, we get a remainder of 6. So it says that the value 38 is an octal is represented by the value 4, 6. So 6 goes here, and the 4 is carried. And then our next computation, wait a minute, look like, okay. So our next computation is 6 times 3, which is the value 18. But we have to add the carry, which is a value of 4. So we have 18 and 4 equals 22. So we have to convert that into octal. And so 8 goes into 22 2 times. 2 times 8 is 16. Then we subtract, gives us the values. The remainder is 6. So 22 is represented in octal by the value 2, 6. And that's what goes here. All right, so we'll move that over here. It's the same thing. We got to be careful of shifts. So we start the 4 there. The 3 is here. 6, 6, 2. All right, so let's clear out. Okay, so the next significant digit is the value 2. We will compute everything from the top. So we have 3, 6, 3, 2. Let's undo that. This would be 2. And then multiply by 2. All right, so 2 times 2 is 4. And 4 is in the set here, so there's no more conversions there. Next value is 2 times 3, which is the value 6. 6 is also in the set of octal digits at the top, right? And now we multiply 6 times 2, we get the value 12. Well, 12 is not in a digit in the set of octal numbers, so we have to convert it. And so we say that 8 goes into 12 one time. 1 times 8 is 8. So we subtract 8 from 12, we get the value 4. So it says that 12 is represented in octal by the value 1, 4. So 4 is placed here, and a carry is carried up. So we have 2 times 3 is the value 6. And then you add the carry, we get the value 7. And since 7 is a part of the set here, there's no conversion needed. So we put 7 there. So we start off here. Just go ahead and move it over and be mindful of the shift that is needed. Okay. And since the next digit is also 2, it's the same computation. Just make sure you shift appropriately. Let's see, it's a 4 here and a 7. And so we perform our computation. And let's clear this out. Okay. So we want to go ahead and perform our addition. So we add to the right, we have a 0. It's carried down. 4 times, in the next significant column, we have 5 times 5 plus 4 would produce a value 9. And 9 is not represented in the set 0 through 7, so we have to convert 9 into octal and divide it by 8. So 8 going to 9 one time. 8 times 1 is 8. We subtract 8 from 9, we get the value 1. And so it says 9 is represented in octal by the value 1, 1. So 1 goes here, and then a 1 is carried. So we're adding 1, 1, 3, 4 in the next significant column. So that's a value of 7 plus 1 is 8. and then another one is also the value 9. This is the same computation we have here, so 1, 1. We will just add a 1 here and carry a 1. So now we have to add the values 1, 7, 6, 6, and 4. Let's see, that comes to be 1 plus 7 plus 6 plus 6 plus 4. That's the value of 24. So we have to convert that to octal. And so 8 goes into 24 3 times. 3 times 8 is 24. We subtract 24 from 24, get a value of 0 as the remainder. And so what this says is that 24 is represented by the value 30. All right, so 0 goes here, and then we have to carry a 3. So that means the next computation, we're going to add 3, 1, 6, 4, and 6. So this is 3 plus 1 plus 6 plus 4 plus 6. Comes out to be the value 20. So we have to convert that into octal by dividing it by 8. So 8 goes into 20 2 times. That's the value of 16. So 20 subtract 16, have the value 4 as a remainder. And what this says is that the 20 is represented in octal by the value of 2, 4. So 4 goes here, and then we carry a 2. So our next significant column, we're adding the values of 2, 2, 7, and 4. So that's a value 2 plus 2 plus 7 plus 4. That's a value of 15. So we want to convert 15 into octal. And that 8 goes into 15 one time. 8 times 1 is 8. And that leaves a remainder of 7. So it says that the value of 15 is represented in octal by 1, 7. So 7 goes here, and a 1 is carried. And then the next significant column, we have the value 8. 8 is not in the set of digits of octal numbers, so we have to convert it. So 8 goes into 8 one time, and 8 times 1 is 8, so we subtract. We get the value of 0. So the value 8 is represented in octal by the value 1, 0. So we have 1, and that carry is a 1 right there. So this is the final computation, but we mentioned earlier that we did all the computations. We had to remove the decimal point. So we said that in the end, once we finish the computation, that we will have to go back and consider adding the 2 digits that we remove. So let's do that right now. Let's look at, let's see here. So this is the final computation. We remove 2 decimal digits. So we start out from the end, and we come here, and that decimal point goes right there. So we look at the positions when we want to show that this octal value 107401.10 is indeed the decimal value 36,609.125. We want to show that it is this value. So what we want to do is look at the positions of the digits in the octal result. So we know that the 1 here is in the 0th position, 0 is in the 1st position, the 4 is in the 2nd position, 7 is in the 3rd position, 0 is in the 4th position, and then 1 is in the 5th position. And then we have a 1 here to the right of the decimal. We said that that would be in the -1 position, because anything to the right of the decimal point, the exponent starts to become negative. Since we have the 0 would be in the -0th position, but when you multiply that times 0, it's going to be 0, so we're not going to compute that. So let's show. We want to show the computation, and what we have is we got 1. We have 1 times 8 to, we say that 1 is in the 5th position, so the power would be 5 there. Plus we have 0 times 8 to the 4th power. Plus we have 7 times 8. We say that 7 is in the third position. Then we have 4 times 8. And the 4 is in the second position. Then we have 0 times 8. And that was in the first position. And then we have 1 times 8 in the 0th position. And then we have 1 times 8. And because that 1 is to the right of the decimal place, it would be in the -1 position. The other 0, anytime we multiply that times 0, we're going to get a 0. So we're not going to include it here. So let's break this down further. We have 1 times, and in our notes to the top left, we say 8 to the 5th power is 32,768. So we have 32,768. Then we have 0 times 4,096. Then we have 7 times, and we say 8 to the 3rd power is 512. And then we have 4 times 8 to the 2nd power, which is 64. And then we have 0 times 8 to the 1st power, which is 8. And then we have 8 times, well, we have 1 times 8 to the 0th power, which is 1. And then we have 1 times 8 to the -1 power. We say that value is 0.125. So we will compute further. We have 1 times 32,768 is 32,768. And then with 0 times 4,096 is 0. And then we have the 7 times 512 is the value 35,084. Then we have 4 times 64 is 256. Then we got 8 times 0 is 0. 1 times 1 is 1. And then 1 times 0.125 is the value 0.125. And so when we add it up, we have 32,768 plus 0 plus 3584 plus 256 plus 1, and then plus the 0.125, and it is indeed the value 36,609.125, and this is what we wanted to show. This puts us in a position for my next tutorial where we describe division of octal numbers. I hope this tutorial was helpful. If you find this tutorial to be helpful, please subscribe to my YouTube channel. Also, feel free to join us at the computing sector. There will be more videos and tutorials coming soon. Thanks.